Okay, now we will do binomials that are not difference of squares, but are difference of cubes. So we want to see if things are perfect cubes. For instance, numbers like 8, because 8 is 2 times 2 times 2. Or 27, because that's 3 times 3 times 3. So those are the types of numbers we're looking for. And if we looked at in both A's and B's, they'd be here, or shapes. These are the reasons I started using the shapes, because the formulas themselves are a little bit more complex. So we're still going to put, if for our first term, we put it wherever there's an A. For our second term, we put it wherever there's a B. But at least I think it's a little easier with shapes, but not everybody does. So if we have W cubed minus 27, first of all, I know that's a difference of cubes, because that's W cubed, that's obvious, minus, that's my difference. 27 is the same thing as 3 cubed, 3 times 3 times 3. So looking at my difference of cubes formula, it says if I have A cubed minus B cubed, which is what I've got right there, it factors as A minus B, so that'll be W minus 3, times A squared plus AB times B squared. That one's a little bit more involved, so let me just do it this way. There's my A minus B. So everywhere there's a blue circle, I put a W. Everywhere there's a red triangle, I put a 3. So there's my W minus 3. There's my W squared. W times 3 would give me 3W, and 3 squared would give me 9 on the end. So again, the way I've gotten these shapes is just everywhere there's an A, I've put a blue circle. Everywhere there's a B, I've put a red triangle. Okay, to check it, I FOIL it out, and all my middle terms cancel. I do get W cubed minus 27. So let's look at 8 minus T cubed. Again, we're going to do this one two ways. With binomials, you don't need to worry about writing it in descending order, but you can. So let's first of all do it as written. That's 2 cubed minus T cubed. So use my difference of cubes formula. That tells me I have 2 minus T, and then A squared, that gives me 2 squared. AB gives me 2 times T, and B squared gives me T squared. So it's 2 minus T times 4 plus 2T times T squared. That's totally fine, absolutely correct, but we will do it the other way, putting it in descending order first. We know it's okay because when we check it, it works. Okay, if we put it in descending order, then I'd have negative T cubed plus 8, but remember, we do not want to factor with the leading negative. So we'd factor out that leading negative, and we'd have T cubed minus 2 cubed, T minus 2, T squared minus 2T, plus 4. And I'd want that leading negative to stay out front. That was just like a GCF that I pulled out. And I'd check it just the normal way, and it does work. So that is a difference of cubes. What if we have a sum of cubes? Well, the formula is right there for us. Once you're used to using the formulas, I could throw any formula in the world up there and you should be okay. So that is something squared plus, something cubed plus something else cubed. If I follow my formula, that says if I have A cubed plus B cubed, it was A plus B, so I have one of each of the shapes in the first set of parentheses, plus A squared, that gives me the blue squared, minus AB, so that's minus blue red, plus B squared, so that's plus red squared. Put an X everywhere I see a blue circle, and a 3 everywhere I see a red triangle, and simplify. So I have X plus 3, X squared minus 3X plus 9. And I would check, just using FOIL or the vertical method, all my middle terms cancel, and I get X cubed plus 27, so it does work. How about R cubed plus 0.001? Is that a sum of cubes? Well, the R cube's obviously cubed. What about 0.001? Think if that's 1 over 1,000. Is 1,000 a cube? Yeah, it is. It's 10 cubed. So that really is R plus 0.1 cubed. Try it on your calculator. 0.1 times 0.1 times 0.1. It does give you 0.001. Plug everything into the formula. Formula is always the same. R wherever there's a blue circle, 0.1 wherever there's a red triangle. Simplify, and I've got R plus 0.1 times r squared minus 0.1r plus 0.01. Check by using FOIL and it checks beautifully. So that is doing the sum and difference of cubes.